Again, review, slope-intercept form. Remember, it has a slope, it has an intercept, so y equals mx plus b. Remember the story that took place last year, the mountain, the skier, he goes up, down, he dies? That m stood for slope, and that b stood for your beginning point, which was your y-intercept. Remember, we only started graphing from the y-intercept. So if you look here at number 1, all I'm looking for is a b and an m. So my beginning point is -3. My slope is up 1, 2, 3, 4, up 4 over 2. 4 over 2 reduces to 2. So now that I have my slope, now that I have my beginning point, I can put it in this form and say that y equals 2x minus 3. Remember that? All right, let's take a look at number 2. My beginning point's -2. My slope is down. It's negative, and I go down 1, 2, 3, 4. Down 4 over 1, 2, 3, 4, 5. So now y equals -4/5 x minus 2. Okay, quick refresher there. And then when we graphed each line, here my beginning point is -1, my slope is 5/4, so I reversed it. My beginning point is -1, my slope is up 5, 1, 2, 3, 4, 5, over 4, 1, 2, 3, 4. And remember, I made you take a straight edge, still going to make you take a straight edge and graph that line. All right, here, my beginning point is 6, my slope is -1. It's the coefficient of x, which is -1, so my beginning point is 6. So it's here, and my slope is down 1 over 1, 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 straight edge all the way through, and I graph my line. All right, standard form. So remember, we said that standard form and slope-intercept form, you can get them back and forth the same way. They're the same line, just written different ways. This one was ugly. You could have fractions, y was on one side, x is on the other, and it looked all kinds of ugly. Standard form was that pretty form, and we said that like ax plus by equals c. Everybody's a whole number. It looks pretty. X and y are on one side. Your constant term on the other side. So it just looks good. But it doesn't give you that slope. So we must be able to convert this into y equals mx plus b to find our slope. Because what we're doing in geometry is slopes are so important when we look at shapes. So we do so much of comparing slopes in geometry. That's why we have to be very efficient on finding slope in everything. Hence the review. All right, so here, all you're doing is getting y by itself. So you just subtract x on both sides, and you have y equals -x plus 6. Now that it's in slope-intercept form, I can see that my slope is -1. Bam. Here to get y by itself, I subtract 5x on both sides. So I get 2y equals -5x minus 2. And now to get y by itself, watch closely, you divide everything by 2. This term by 2, this term by 2, and this term by 2. And then I reduce it. Remember, math is all about equality. So I get y equals -5 over 2x minus 1. Now my beginning point's -1. My slope is -5/2. All right, let's do some more practice over. I'm going to do 10 and 11 here. So subtract 3x on both sides. Notice I'm left with -y equals -3x plus 5. This is the same thing as dividing everything by a -1, which basically flips my sign. It's going to make this positive. It's going to make this term positive 3x and make this term -5. It changes everything. So if I divided everything by -1, notice negative divided by negative is positive. Negative divided by negative is a positive. Positive divided by negative is a negative. But I know that my slope here is 3 and my beginning point's -5. It's very easy to identify. All right, let's take a look at number 11. To get y by itself, I'm going to subtract 6x on both sides. I get 8y equals -6x minus 16. And now I'm going to divide everything by 8. It's that equality, so it's everything divided by 8. And I get y equals reduce to -3/4 x minus 2. And easy to identify there in that slope. All right, so same way, when we graph each line here, I'm just going to turn it into y equals mx plus b. So I subtract x on both sides. I get -2y equals -x plus 8. Divide everything by -2. And I get y equals 1/2 x minus 4. Okay, so hopefully you slowed that down and You remember from last year. So now my beginning point's -4. My slope is up 1 over 2, up 1 over 2, up 1 over 2. And I go all the way through. All right, let's do number 14 just because any extra practice is good. So I get 5y equals -3x plus 5. Now I'm going to divide everything by 5. And I get y equals -3/5 x plus 1. So my beginning point is +1. My slope is down 3 over 5. And I can reverse it and go up 3 over 5. Either way, you know that your line is negative. All right. Remember, these are my very, very special cases. So when I had a special case, I know that my slope is undefined, right? I know it's undefined because he's dead. So this is that case where x equals something. X equals -1. Through all these points, x equals -1. So you identify where does it cross your x-axis, crosses it at -1. The equation is x equals -1. Over here, my equation is y equals 3. That's the equation because no matter what, y is always equal to 3, and my slope, of course, is 0. So that's a special case. So real quick, if I want to graph these lines, if I graph y equals 4, I identify where my y-intercept is 4. 1, 2, 3, 4. 0 slope goes all the way through, just like that. Where's my x-intercept? -2, and it goes through all of that. It's -2. He's undefined. This is a bad, bad situation. He's dead. X, you can't even put x equals -2 into your calculator. Bad situation. He's dead. Y equals 0, so zooming straight across at 0. And it looks like that. All right, so now when we look at these lines, the whole purpose of this is for me to decide, are my lines parallel, perpendicular, or neither? So I'm going to go down this column, and I'm just going to look at my slopes. All I'm doing is I'm looking at my slopes. 5 and 5, same, parallel. Not easy to tell my slope here. So what I have to do is I've got to take it from standard form into slope-intercept. So I'm going to subtract x. I get 2y equals -x plus 2, divide everything by 2, and I get y equals -1/2 x plus 1. I don't even have to do the y-intercept, but why not? Over here, I subtract 6x everywhere, and I get -3y equals -6x plus 21, divide by -3, and I get y equals 2x minus 7, -1/2 and 2. Notice these are negative reciprocals. Negative reciprocals makes it a perpendicular. Those lines are perpendicular. All right. This one is already in slope-intercept form. Awesome. I like it. That's easy. This one needs to get there. So I subtract 3x on both sides. I get -y equals -3x plus 2. Divide everything by negative to get y equals 3x minus 2. So look closely here. This is 3 1/3. It looks like it's perpendicular, but they're not negative reciprocals. This would have to be a -3 for it to be a negative reciprocal. So this is neither. This is a tricky one. Make sure to pay close attention. All right. Oh, I love you, girls. So make sure to pay attention. I get y equals -1/4. My slope is -1/4. Here, I subtract 2x on both sides to get 8y equals -2x plus 56. Divide everything by 8, and I get y equals -1/4 x plus 7. So -1/4 and -1/4, both exactly the same. Parallel lines, box it. All right. This is 0 slope. If I graph it, it's 0 slope at -7. This is undefined. What kind of lines are those? 0 and undefined create perpendicular lines. Be careful on that one. All right. So this one, you would just have to convert all of these into y equals mx plus b form and see which one has the same slope. So the same slope is going to be 1, 2, 3, 4 thirds. So you're looking for which one of these is positive 4 thirds. I'm not going to work all these out, but I will tell you after you pause it and answer 28 and 29 for me. Okay, you bet? All right. So 28, the only other one that has a slope of positive 4 thirds is D. Hopefully you got that. Over here it needs to be perpendicular, so you would notice that your slope is -1 over 1, 2, 3, 4, 5. So if this is -1/5, the perpendicular one has to have a slope of 5. So the only line that has a slope of 5 over here is A. So A would be my answer there. Okay, so that's your refresher for that one.